Hello everyone, today we will be starting with electromagnetic induction. This is lecture 1 part 3 of electromagnetic induction. I am Sameer Lavankar, so let us begin. Let us move on to experiment number 3. So what does the experiment number 3 by Faraday and Henry tell us about? Before starting the experiment, please make sure a new thing involved in the experiment, which is a tapping key. Tapping key is nothing but anything which is involved for completing a circuit. Let us say this is a bulb, here it is a tapping key and here it is a battery. So now this circuit is, for now it is an open circuit. Why it is an open circuit? Because the wires are being not connected in the right directions in this position. In this position the wires are not connected. So what does tapping key does is, say as we tap here, the connection becomes closed, and hence due to this battery a voltage difference will be will complete here, a voltage difference will be there, and hence the light bulb will glow. So this is only the concept involved behind tapping key. Everything else is known to you already. You know C1 is a coil, C2 is also a coil, then this is a battery, this is a battery, this K is a tapping key, this K is a tapping key, and this G is a galvanometer. So this was only the thing which I need to tell you before experiment number 3. So now let us move on to experiment number 3. I will explain to you line by line. So the above two experiments as in experiment number 1 and experiment number 2 involved relative motion between a magnet and a coil and between the two coils. So this is experiment number 1 here and this is experiment number 2 here. Through another experiment, Faraday showed that this relative motion is not an absolute requirement. So the conclusion statement of the first and second experiment was that a relative motion is required. Again, a relative motion is required. So what does Faraday told in the experiment number 3? That everything which was being told you before is okay, but for induction of current it is not an absolute requirement that a relative motion is required. So to explain this concept more, he performed this experiment number 3. Okay. So the figure on the left shows two coils C1 and C2 held stationary. Please make sure that these are stationary for now. Nothing is moving in experiment number 3. Coil C1 is connected to galvanometer G. Coil C1 is connected to galvanometer G, while the second coil C2 is connected to a battery through a tapping K key. While the second coil C2 is connected to a battery through a tapping key K. It is observed that the galvanometer shows a momentary deflection. What does momentary deflection? Let me complete the statement first. It is observed that the galvanometer shows a momentary deflection when the tapping key K is pressed. So when you press this key, it will show a momentary deflection. Momentary as in it is like this, very quickly it will go here and then I will again come here. So this is known as momentary deflection. It is observed that the galvanometer shows a momentary deflection when the tapping key K is pressed. Now why is it happening? The pointer in the galvanometer returns to 0 immediately. So this is the concept I told you, that it is like this, a momentary deflection was being involved like this, and then it goes again to its stationary position, in its original position, not stationary position, original position. To be more clear, the pointer in the galvanometer returns to 0 immediately. If the key is held pressed continuously, that means that if we keep pressure, let us connect it here like this, let this be like this only for a long period of time. If the key is held pressed continuously, there is no deflection in the galvanometer. Very important point. We may understand it like this, let us say there is a circuit which is already being made, but we know that there is a relative motion required. So, if a relative motion is required, then that means that anything which is a complete circuit with a stationary position cannot induce current. This is the concept which was being told in first two experiments, and the same principle is involved in experiment number 3 only. That is why there was a momentary deflection. I will explain it more if it is not clear. For now, let us move to next point. When the key is released, so you will release the key, a momentary deflection is observed again, but in the opposite direction. So, opposite direction as in, if the deflection first was towards right direction, then this time the deflection will be towards left direction. It is also observed that the deflection increases dramatically when an iron rod is inserted into the coils along their axis. I will explain it a little bit later. First of all, I will try to explain you why is there a momentary deflection and why was there no deflection when the circuit was being completely was complete. So, to explain these three concepts, so now what is happening is, let us say I will make a coil C2 here. Let us say I will make a coil C2 here. Which is connected by a tapping key. This is a battery. Now, what will happen is, for now when this is a open circuit, there is no magnetic fields which are being made. No magnetic field is available. No magnetic field is available. Now, what will happen is, at that instant, let me explain it like that only. At that instant, when the tapping key is being pressed, what will happen is, let us quantize this magnetic field. Let us say there is nothing, means let us say there is a rope. For now there is no rope here. Let me explain you like this only. Let us say there is a point A, there is a point B. For now let me explain it like that magnetic field is a line or a rope. So, for now when the circuit was open, there was no rope here. If there is no rope, there is no induction of current, there is no induction, and hence there is no current. At that instant when the key was pressed, a rope started to appear. So, this rope started to appear as in the magnetic field started to appear, the magnetic field started to grow. So, what was happening is, let us say in the subsequent slide we will know more about magnetism, but let us say magnetic field was 0 first. Let me explain it by a quantity only, it was 0 first, and then it goes to, let us say 5 units. Let us not go towards the unit point, let us say 5 units. So, there was a change. If there was a change, there was a relative change, and due to this relative change there was an induction in the current. This is only the concept involved, and why only a momentary deflection was being involved. A momentary deflection was being involved because, why was momentary deflection was being involved? Momentary deflection was involved because the time it took the magnetic field to attain its stability toward this 5 units was very short, and in that short deflection there was a relative change, and because there was a relative change, hence there was a induction in the induction, and hence there was a current. As 5 units was being achieved, as it was stabilized, as the magnetic field was stabilized, the magnetic field is stationary, hence there is no movement, hence there is no induction. So, this is only the concept involved. In real scenario, there is nothing called as rope. All the magnetic fields are either wavy culture, in wavy nature, these are magnetic fields. So, this is a magnetic field. For a coil, these will be magnetic fields like this. So, for understanding the concept, for just to make sure you understand the concept, I told you by a concept of rope here, that there was no rope. So, everything was 0, and then in that momentary time, it got its magnetic strength, it wants to attain its stability, let us say that was 5 units. So, in that delta t time, what it does was, there was a relative change, and hence there was a change in there was an induction and hence there was a change in current. And because after that time t was completed, the stationary there was no the coil was stationary, the battery was stationary, everything was stationary, magnetic field, relative change in magnetic field was 0 and hence there is no current induced. So, this is only the concept which was being told in experiment number 3. Moving on to the last point. So, everything has been told to you. Moving to the last point, it is also observed that the deflection increases dramatically when an iron rod is inserted into the coils along their axis. So, what does this line tells you about? What does an iron rod do? If you if I elaborate more, I explained to you I think 5 to 6 slides back is anything, an electric conductor if wound around a coil, if a coil is being wound around an metallic thing, not a metallic thing, any conductor, and electromagnetism occurs, and electromagnet is being made. So, what does this conductor does it increases that magnetic field units. So, what will happen is, if I explain you by this same concept, let us say this time what happens is when an iron rod is being inserted, let us say in this magnetic field from here or anywhere, an iron rod is being inserted in that magnetic field, the magnetic amount or the magnetic field amount increases sharply to let us say 500 units. So, because and the time is almost delta t only. So, because the units are being very large, a 495 unit surge and the delta t is same. So, the deflection which you will get is very large as compared to this 0 to 5. So, this is the same concept which was involved here only, just because there was a change, there was a very high change in magnetic field and hence the current the deflection which was involved is more. So, these were the 3 experiments which were told by Faraday and Henry. The first involved a magnet and a coil, the second involved a coil and a both were 2 coils were involved, and in third, just to introduce, just to applicable, just to make sure that there is no induction or there is no requirement for a thing to be moving, or relative motion is not relative motion is only necessary, just to make sure that this criteria is not possible, or not only the criteria which is important for electromagnetic induction to occur. This third thing, which is use of tapping key and battery, was involved. So, these were the 3 experiments. And hence the first lecture summary is what we learned today was, first of all we started with electromagnetic inductions introduction, the definition of electromagnetic induction, we learnt about Oersted and Ampere, followed by the 3 experiments of Faraday and Henry. We learnt many applications or inventions of Faraday and Henry also, like telegraph, then electromagnet, then electromagnetic motor and so on. We also learnt about all the units which were being used in the experiments by Faraday and Henry, like galvanometer, then there was a coil, then there was bar magnet, then there was tapping key. All these concepts were being told apart, followed by explanation of experiment 1, experiment 2 and experiment number 3. So, just to conclude, till now we have completed lesson 1 and lesson 2. In the next lecture I will explain to you what is all the fuss about this magnetic flux. Everything which I told you, that this is 0 units, this is 5 units, this is 500 units, I will explain it more clearly by the concept of magnetic flux. And hence, to conclude, thank you.